Okay, so for 3.3F polynomial geometry, again, this is notes and practice. So we're not going to do every single problem together. We're going to do a few of them together, and the rest are going to be left for you to practice independently. Practice being that is your choice to just be better at it. Does that make sense? It's not an assignment. It is you practicing and making sure you really understand what we're doing. So we're going to scroll down to where we left off at. Bless me. Thank you. So numbers 1 through 9, we were finding area, perimeter, and volume, right? Yes. Bless me. For numbers 10 through a while, a lot of them, we're also finding area, but we're finding area of a shaded region. Can someone raise their hand or say loud and proud, how do you find the area of a shaded region? Bam, exactly. You're so smart. I knew it. Okay. So to summarize what Annabeth said, we just find the big minus the small, right? And so we've already proven to ourselves that we can find the area of rectangles. We can find the area of triangles. We can find the area of squares and circles, right? Now it's just instead of finding one area, we have to find 2 areas. So if you look right here on number 10, we're going to do together. And then I'm going to have you do 11 and 12. So number 10, the first thing we are understanding, to find area, it's going to be the big, I can spell, the big minus the small, right? So we're going to find the big rectangle first. The big rectangle, the length and the width is h plus 2 and 3h, right? So length times width. And what does that give me? There we go. 3h squared plus 6h. Agree? All right. Now we're on to the small. And the small equals 2h squared because it's 2h times h, which makes 2h squared. All right. Found it. Now we're going to do our big minus our small. So we have 3h squared plus 6h minus 2h squared. When you're adding and subtracting with variables, they have to have what? Like terms, right? So what are my like terms? So I have 3h squared and negative 2h squared. What does that make? Just h squared. So h squared plus 6h would be our shaded region. You can't go any further unless you know the value of h. And do we know the value of h? No. That's only when you are dividing. And we only subtract exponents when you're dividing the variables. All right. Okay. I'm going to pause and give you, let's say, 2.5 minutes to do 11 and 12, and then we will check back. Cool? All right, go. All right, let's see how we did. So on 11, what's the area of our big? Good job. And so for the area of big, you have your x, and then this is 2x plus x. So that makes what? 3x. So that gives you 3x squared. The area of your small, it's just going to be 3x, right? Its length and its width is 3x. So again, you're subtracting big minus small. So we have 3x squared minus 3x. That's it. That's all you could do. The only other thing is that you could do is that most mathematicians would like to simplify this. And so if I wanted to simplify this, I would just factor out 3x. And that's all you can do. There's not much else you can do. Because do we know the value of x? No. All right. Let's go on to 11 and 12. 12, it says find the area of this one. So again, our big was what? For our square, what was our small? So what was our area? 3x squared.
Yeah.
That's it. Remember Casper the Friendly One. Casper the Friendly One is there. Okay. How do we feel? Doable? All right. Hold on, you see nothing. You saw nothing, you saw nothing. All right, so on here, as you can see, the rest are also the same, right? So we're not gonna do, these are gonna be left for you to practice. They're all the same, just different numbers. For the most part, the only one that I wanted to talk to you about, I'm gonna do one of them, which is it. So I was either gonna do 13 or 16. Which would y'all want me to do?
16.
16? All right, 16 is the winner. The reason being is that for this one, you're subtracting more than one term at a time. So, yes. So we're going to do 16, and then the rest are going to be practice. Got it? So on 16, the area of my big, so I'm going to do the big, which is going to be length times width. So we have 2x times 2x plus 1, and that's going to equal right? Easy enough? All right, then we're going to do the small. The small here equals x minus 1 times x minus 1. This would be what situation takes place? FOIL, right? I would have to FOIL. That's going to give me x squared minus 2x plus 1. Okay, do y'all remember when we were doing long division and I said when you're subtracting the polynomials, you have to change the signs of each term of all the terms? That applies here. So when we're subtracting this, it is 4x squared plus 2x minus x squared minus 2x plus 1. This is why you have to change the signs, because that minus is affecting every single term, right? So when I'm doing it, it's actually 4x squared. My pen did something weird there. I don't know. It's my pen. It's tired. Okay, you have to change every single sign. You can't just change the first one. You have to change the sign of all of the terms. All right, now we just clean it up. It didn't even make it. Okay, there we go. So first up, we have 4x squared and negative 1x squared, and that gives us perfect. Plus 4x and then minus 1. So that would be the area of the shaded region. Okay. So just make sure when you're subtracting more than one term, you have to subtract all of them. Right. Huh? Okay. Let me finish answering hers right now. So here on the combining, so 4x squared and negative 1x squared made 3x squared.
So you change the sign.
So here you have to change because you're subtracting the entire thing. So if I'm subtracting the entire thing, it's going to have to be, each one's going to have to be subtracted. So it became negative x squared. A negative times a negative is a positive. A negative times a positive is a negative.
Okay.
I don't know. I'm
It's fine.
there's a 1 here, so it's distribution of that negative 1. When you're subtracting something, you're multiplying by a negative and taking that away, right? So that's all we had to do. We couldn't just put a subtraction and only subtract x squared. We have to subtract all of them. So then we end up with 3x squared plus 4x minus 1. Okay. All right. The last ones that we're going to do are the last three. Yes. Sure. All right. And then this will conclude our geometry section of polynomials. So these are our last three type. Now, again, it's kind of a like, I don't know what we're going to get. So that's why we have a variety. So here it says find the volume. Okay. So we have three sides with three terms. What I wanted to model here is that when you're multiplying with polynomials, just write them out and multiply from left to right. That's because order doesn't matter when it comes to multiplication. It has what's called commutative, and associative properties. Okay. Yes, which means that I'm allowed to multiply in whatever order, and I'm allowed to multiply whoever group together I want, right? Because the result is still going to be the same. The only thing I strongly suggest is that you put your monomial first, distribute, then FOIL. Other than that, you do you, boo. All right, here we go. So volume here, I have my length, my width, and my height. So I'm multiplying all three. So we have 2x times x plus 4 times x minus 3. So when I say work from left to right, you only can multiply two things at a time. So left to right, we're doing 2x times x, which is, then we have 2x times 4, 8x. And now I'm down to this. And now I'm going to FOIL, right? So we distribute. Now we're going to FOIL. So we have 2x squared times x, 2x to the third, 2x squared times negative 3. Perfect. 8x times x. Perfect. And then 8x times negative 3. Okay. I've now fully distributed, got rid of parentheses. So my last thing to do is combine like terms. So my like terms are, and what does that make? There we go. So we have 2x cubed plus 2x squared minus 24x. Yes, there are additional practice. Okay. How do you feel about multiplying more than one polynomial? Doable? Okay. Again, just go monomial, binomial, binomial, multiply left to right. Okay, so the volume here was 2x cubed plus 2x squared minus 24x. All right. So now we're going to do the circle inside of the rectangle. Again, just because they're not the same shape family, is the process going to change? No, it's not. You said, yeah, it's not. It's not. We still got to find our big and our small, right? So the area of the big, what's the area of my big? 10, and it's because you have 10x times 5x, which makes 10x squared. Then I'm going to find the area of my small. How do you find the area of a circle? You need pi r squared, right? Pi r squared. So I need to know the radius. Well, from looking here, I know my diameter is what? 2x. So what is my radius? 1x, right? Because x plus x is going to give me 2x. So therefore, this is pi x squared. Yeah? And what do I need to do with these two? Subtract. So we have 10x squared minus pi x squared. Now, since we don't know the value of x, is there any reason for me to make pi into a decimal? No. So all we're going to do is clean this up, and we're left with x squared is 10 minus pi. So as soon as I know x squared, I will put that in and I can figure out the rest. But this is my exact value of my shaded region. Okay. All right, last but not least is an example of when you have enough information to solve for your variable. So this time I should get a numerical answer. Huh? We're on number 44. Oh. So in 24, it says the total degrees in a triangle is 180. Find the measure of the third degree. Do y'all remember that from geometry? The interior angle sum is 180. No, just the sum of all three angles has to equal 180, right? So they gave me all of my, do they give me three angles? Yes. So I know that 180 equals x plus 15 plus 2x plus 1 plus x. Can I solve for x? Yes. What is step one to solve for x? Combine my like terms. So we have 1x, 2x, and 1x. What does that make? 4x. Then we have 15 and 1. And what does that make? 16. Oh, look, a good old algebra problem. What are my two-step for this two-stepper? There we go. And what does that leave me with? What'd you say? 164. There we go. And then my last step is? Okay, what is the value of my x?
It is 39. It's 41.
It's 41. What are you doing? 4 goes into 16 4 times. 4 goes in 4 1 time. But how did you have those numbers?
I did 4 times 25 gets into 100. 4 times 10 gets into 40. So now I have 40. That's 25. That's 10. There's 35. And then I just need what's left? 24. So how much 24 rather? And I guess it's
Yeah, you were getting there weirdly, but yeah. You just had to do this. 4 divided by 16 is 4. 4 divided by 4 is 1. 41. Yeah, it's called shorthand division. Yep. I mean, your way was fun.
all right.
I was like, what? Why are you throwing these numbers at us? So x equals 41. So if I had to find the other two angles, could I find them? Yeah, I could. So just let's do it for fun. What would be the measure of this angle? 43. Good job. Yeah. What would be the angle of this angle? Oh, measure of this angle, 56. You know what I meant? Angle of this angle? Interpret me. All right, easy enough? Okay, so we only can solve for the variable if we have it equal to a number. Does that make sense? And in this case, were we able to do that? Yes. All the other ones, all we had to do was just simplify as much as we could because we did not have a way to solve for that information. Got it? All right, that concludes our polynomial geometry.